All right, here we go. All right, here's the wheel of algebra again. Mrs. McInerney is trying to make algebra a little more exciting, so she's going to use the prize wheel again. The spinner must always start from the position shown above. So remember, it's going to start, oops, that was the wrong one, over here to the far right. So that's the positive x-axis. The spinner must always start and spins counterclockwise. If you land on a line, you can pick which sector you land in. Begin by labeling the angle measures of each sector in radians. So if you scroll down, do you see the prize wheel? So I'm going to scroll here. And so you do need to stop and think a moment. Do you see I have 1, 2, this is 3 regions. So how much is each wedge on this prize wheel? 30. Okay, so you're going to go 30, 60, 90, 120, 150. Oh, wait, and it wants us to do this in radians, doesn't it? So I'm going to first go in degrees. Now the 3 main angles, 30 degrees, 45, and 60. You want to begin to memorize those 3 in radians. Let me repeat that because this is really important. Your 30 degrees, your 45, and 60. You want to memorize what those are. So I'm going to do it real quickly. If I want to convert 30 degrees into radians, I multiply by pi over 180. What does that reduce to?
60.
Not 60. Oh, okay, so 60 goes into, no, 60 doesn't go into both. It's pi over 6. Okay, yeah, 30 goes into both, so you're getting your 6 there. So I'm going to use a different color so you can see this. So this in radians is pi over 6. Do you understand that's 2 pi over 6? Which reduces to pi over 3. This is 3 pi over 6, which reduces to pi over 2. I have 4 pi over 6. What does that reduce to? 2 pi over 3. Then I have 5 pi over 6. I have 6 pi over 6, which is pi. I'm going to pause and give you a head start, and you do the bottom rotation. All right, so 210 is 7 pi over 6. This one's 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6 is 4 pi over 3. 11 pi over 6. Then 12 pi over 6 is 2 pi. So do you see how I just went around with pi over 6? All right, so I want to give you a few minutes, and I want you to try these questions. Number 1, Melanie really wants to win extra homework, so go find where extra homework is. What is the smallest number of radians she can spin in order to win? Then sketch it to the right. Then Melanie actually spun 11 pi over 3. Did she win sketch it, make a little circle and sketch it. So go ahead and try 1, 2, 3. And then did I cut off 4 on yours? Yeah, okay. That's what I thought. And you want to put all your answers in radians this time, okay? Now that we're working with radians. This period's over at 9:55. We're running on SSR and tornado drill.
Our tornado drill was terrible.
I will grant you that. Yes, I agree. But that's how you learn.
Yeah, I don't know if kids who stay in front of the classroom. Yeah, we don't be, I think, away.
Again, try 1, 2, and 3. See how far you can get. And if you have to do degrees, then pop them into radians. Or look at your prize wheel that we labeled. See if you can identify the radians there. All right, turn to your neighbor and share as far as you got with your neighbor.
The first one.
For the 3A though, thank you on minus 225 over 360.
I think it's this one because that's the highest. Because if you land on a line, you can choose which.
Oh, 300 is lower than.
Yeah.
Okay.
All right, so here we go. Melanie really wants to win extra homework. What is the smallest number of radians she can spin in order to win? So let's go down to the prize wheel. And do you see where extra homework is? Whoops, I just caught that. That was 330, right? All right, between what two wedges or two angles is the wedge for extra homework? Brennan, between what two? Okay, 300 degrees and 330. So what's going to be the smallest that you could spin and still win that prize? And I love how you answered it. Okay, we want to do this in radians, so it's 4 pi over 3. Whoops. Right? So that's going to be 4 pi over 3. Or not 4 pi over 3, sorry. Did I write that wrong? I did. Jeez, you guys, I'm having a rough morning here. Okay. So that's 5 pi over 3. Fix it for me. That was because we already had 4 pi over 3. That's 5 pi over 3. There we go. So that's 5 pi over 3. So you're thinking in degrees, but also radians, if that can make sense. So that's 5 pi over 3. It was 10 pi over 6, but we reduced it to 5 pi over 3. All right, number 2, Melanie actually spun 11 pi over 3. Did she win extra homework? Somebody who feels confident. What do you think? Yeah, DP?
Yes, she did.
Okay, so she did. How do you know?
Wait. I don't know. I thought it was 11 pi over 6. Not over 4.
Well, then it was a happy accident. Yeah, Jake?
The way that I did it, I knew like double that was 22 pi over 6. And then,
Okay.
I don't really. I lost it.
All right, Mia?
I had 5 pi over 3, and then since 360 was 2 pi, I added 6 pi over 3. I mean,
Oh.
and then it
Nice.
was 11 pi over 3.
Okay, so in order to see if she won, she added 2 pi. Here's another way to think of it. Here's how I did it. I subtracted 2 pi to see if it was, does anybody remember what was it called when it's the same coterminal? I wanted to see if these were coterminal angles, and they are. So it is yes. So what's going to happen is I'm going to draw the same angle, but I'm going to whip it around one full time and then the 5 pi over 3 or 300 degrees. Does that make sense now for those of you that were confused? Does it clear that up, I hope? Number 3, if you land on the starred line, you get an extra spin. Caitlin spun 5 pi over 4. How many radians was she from getting the extra spin? Now, if you do this in radians, so look at where 5 pi over 4 is. Oh, we don't have that. Okay, here, wait. So do you remember? This is pi over 4. We did this on Friday. This one was 3 pi over 4. This is 5 pi over 4. And 7 pi over 4. Do you remember? And then we did 2 pi over 4 was 90, but we reduce. 4 pi over 4 was pi, and we reduce. So how far away is 5 pi over 4 from getting to the prize line? The starred line. Pi over 4. Now here's how you figure it out. If this is 0 on the right side and pi on the left side, isn't pi 4 pi over 4? So now you can begin to understand why I assigned the homework that I assigned. The adding and the subtracting with 2 pi or pi, because we need this. So I want to know, does anybody remember when we did degrees? What was the special vocabulary from the x-axis to the terminal side? Reference angle. Okay, so up here, This was coterminal angles. This is a reference angle. And so theta prime, you take pi, whoops, but I was also going, so I'm going actually from here to get this theta prime. So that is 5 pi over 4 minus pi. So theta prime, or the distance from 5 pi over 4, that terminal side to the x-axis. So here's the big idea. It's going to be the distance in general, okay? In general, the distance from the x-axis is going to be from 0, pi, or 2 pi. All right, suppose your friend Jeremy is telling you about how exciting Algebra 2 was in the prize wheel and tells you that he was pi over 6 away from winning an extra spin, but he didn't tell you where he was. How many radians could he have spun? All you know, because he was vague, is that he was pi over 6 away from winning the extra spin. So now you've got to figure out, where was he?
Where's the extra spin?
The extra spin is the horizontal starred line, which is the x-axis. So do you remember here at number 3, it says, if you land on the starred line, you get an extra spin, right here. All right, so isn't one of the angles pi over 6? Like you could have been in the first quadrant. What would the angle be in radians in the second quadrant?
5 pi over 6.
5 pi over 6. What would it be in the third quadrant?
7 pi over 6.
7 pi over 6. And what is it in the fourth quadrant? 11 pi over 6. Do you see how we do that? It's either on the left side. Okay, if I'm coming from the left side, you're going to take pi minus pi over 6 into the second quadrant, pi plus pi over 6 to get third quadrant, and fourth quadrant is 2 pi minus pi over 6. So now there's a method to my madness, okay, when you are oftentimes looking at homework saying, why is she asking us to do that? There's a very good reason. I wanted you to be able to practice fraction work with pi. So a few of us struggled with it, so I need you to get to Math Lab, make sure today when we have some time that you're asking for help. All right, so let's fill in the quick notes. This is what we learned. Coterminal angles in radians. What was it we did to find coterminal angles in degrees? Anybody remember? Add or subtract 360. So then what do you think you're going to do here? Add or subtract 2 pi. And the way that you do that is build a common denominator. For example, like 4 pi over 2, 6 pi over 3, 10 pi over 5 to build your 2 pi. So here's the good news. Coterminal angles are not new, okay? Coterminal angles are not new. We're just now going to go through and do them instead of add and subtract 360. We're going to add and subtract 2 pi. It's a little tricky because you have to build common denominators. Reference angles. This was our second thing we just discovered again. Is it's the distance from the x-axis. And you're going to label your x-axis as 0, pi, and 2 pi. And then you're going to write the fractions with a common denominator as the given angle. So again, a reference angle is the distance from the x-axis. So you want to label the x-axis 0, pi, and 2 pi. Write fractions with common denominator as the given angle. So let's look at number 1. It says sketch 7 pi over 6. Does yours say 7 pi over 6? Okay. So go ahead and sketch it and then see if you can find the reference angle. In number 2, it's connected to number 1. Give a coterminal angle, so you'll add or subtract 2 pi. And then number 3 is different. Draw the angle, or did I cut off 3? Do you have a 3?
Yeah.
You have a 3. Okay, all right, then try 3. So I'm going to give you 3 or 4 minutes for you to try these. Now be careful. If your given angle is in radians and you're asked for a reference angle, your reference angle must be in radians. If you do where you flip to degrees and figure it out, that is fine. That is an acceptable technique. But your final answer needs to flip back to radians. If you're given degrees, your answers will be degrees. Does that make sense? Let me say that again, because this is really, really important, because as I'm walking around, I've seen some of you with degree answers. That's okay to figure it that way. I'd love you to think in radians, but this is new, so if you need to put in degrees, figure it out. That is an acceptable technique. However, if the given angle is radians, your reference angle or coterminal angles must be radian answers. Okay? All right, Hannah, 7 pi over 6. Can you tell me what quadrant is the angle in? Awesome. Okay, that's in the third quadrant. Okay, that's in the third quadrant. So this is 0, pi, 2 pi. So then, well, here's how I figure these out in radians so that I don't have to go to degrees. Okay, let me kind of explain this for those of you that are struggling. 7 pi over 6, I label 0, pi, 2 pi. I can tell this is a teeny tiny bit more than pi because it's pi would be 6 pi over 6. So 7 pi over 6 is 1 pi over 6 in. And the thing is, you've got to remember pi over 6 is 30. What's pi over 3? 60. And what's pi over 4? 45. You have to know these three like the back of your hand, so you might as well just you can always figure them out, but it's quicker if you start to memorize them. So what this means is I'm 30 degrees in. So my reference angle would be 7 pi over 6 minus pi, but pi is 6 pi over 6. So the reference angle is pi over 6. Just because 1A and 2A go together, if I want to do a coterminal angle, you can either add 2 pi or subtract 2 pi. Either works. So then you've got to build a common denominator. If you subtracted, anybody who subtracted 2 pi, what'd you get? Or can you do it quickly in your head? If I take 7 pi over 6 minus 12 pi over 6, what is that? What's 7 minus 12? Negative 5. So that's negative 5 pi over 6. It didn't specify how or what direction to do. All right, 5 pi over 3. Here's how I do this. I do 0, I do pi, and I do 2 pi. Well, pi is 3 pi over 3. So I know one more into the third quadrant is 4 pi over 3. I know 2 pi is 6 pi over 3. So 5 pi over 3 is in the fourth quadrant. And then my reference angle would be 2 pi minus 5 pi over 3. Does that make sense? How you figure it out. Then a coterminal angle. You're just going to take 5 pi over 3 plus 2 pi. So I hope you know I've got your back. That homework that you did due today was intended to make your life easier. I was trying to get you to practice how to add and subtract so that today's lesson would be easier for you. So anytime we're doing problems and you wonder, why is she doing this? I don't understand. This seems a little out there. There is always a reason, okay? Just trust me until the reason becomes clear. All right, then the last two here, it says draw the angle, and then we're going to find the exact value of the trig function. So this is cool. We're going to make a beautiful connection, and this is going to end up helping you for your unit circle quiz. It's all in degrees today, but we're going to end up really doing these in degrees. So 3 pi over 4. So here's what I want you to remember. Here's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I strongly recommend the pi over 4s, you just memorize them. It goes 1, 3, 5, 7 in the middle. 1, 3, 5, 7 with pi over 4. So this is second quadrant. What's the reference angle? How far is 3 pi over 4 to pi? Pi over 4. Well, pi over 4 is 45 degrees. So here's how we're going to work this. I'm going to do the sine of 45 degrees. Have you been doing these enough, or you draw your triangles? I guess we can do that because you need that today. So it goes 1, 1, square root 2. All students. Then in the third quadrant, the sine of 3 pi over 4 is still positive square root 2 over 2. Okay? So all you're going to need to do is know those 3 radians. Pi over 6 is 30 degrees. Pi over 4, 45. Pi over 3, 60. And then you do just what we did before. Okay? So let's try cosine 11 pi over 6. So let me pause. Let you try this. While I'm doing that, I'm going to multitask. I'm going to put the quick quiz face down. Don't turn it over. See if you can get the whole way on cosine 11 pi over 6. All right, here we go. 11 pi over 6. Drew, what quadrant is 11 pi over 6? Just the angle. Good job. It's the fourth quadrant. Then, Elise, how far away from 2 pi is 11 pi over 6? Good job. And here's how you would figure it out. Take 2 pi minus 11 pi over 6. So that's the pi over 6 away. Well, so my reference angle is pi over 6. Pi over 6 is 30. So let's review our 30, 60, because you need that today. And I'm really hoping that those of you that try that cram and dump, cram and forget, that if I keep after you, where we're having like these quick quizzes several times a week, I guess the hope is if you're cramming, you're going to eventually remember them. So I want the cosine of 30. Humira, what's the cosine of 30? Okay, then all students take calculus. Emma, would cosine be positive or negative in the fourth quadrant? Positive. So now make sure you are going back to the original problem. Cosine 11 pi over 6 remained positive.